All right, so in this video, we're going to go through sample question 82 from the Society of Actuaries ExamP list of sample questions. The question reads, an insurance company issues 1,250 vision care insurance policies. The number of claims filed by a policyholder under a vision care insurance policy during 1 year is a Poisson random variable with mean 2. Assume numbers of claims filed by different policyholders are mutually independent. Calculate the approximate probability that there is a total of between 2,450 and 2,600 claims during a 1 year period. Okay, so very wordy problem. Let's try to take out the important informations. Insurance company. Vision care policies, Poisson random variable with mean 2. Now, I love Poisson random variable. It's very loose. I love Poisson random variables because the expected value of a Poisson random variable, x, is equal to the variance of it. And that, for me, just makes things a lot easier to deal with. And we know that's 2. Now, we also know that they're mutually independent policies, and they're all identical to each other, right? And that should give you a slight key. We're dealing with a lot of different identical, independent items. We need to calculate the approximate probability that the total of all these policies, of all 1,250, is between 2,450 and 2,600. We're going to use the central limit theorem. Okay, so we need the random variable we're interested in is the sum of all these 1,250 claims. So I'll just use S for sum, right? Seems easy enough. And that's equal to, let's say x of 1 plus all the way to x of 1,250. And we're going to need the expected value as well as the variance for S. So the expected value of S is simply the number of claims we have, 1,250, multiplied by the expected value of X, which is 2. And that is 2,500. Similarly, we can get the same result for variance, right? And like I said, because we're dealing with Poisson random variables, exact same thing. 2, running out of room a little bit, 2,500. So the expected value and the variance for the sum of all these vision care policies is 2,500. So how are we going to use this? Right, we need to find the probability that the sum of all these policies, make sure that's in frame, that the sum of all these policies is in between 2,450 and 1,600. 2,600. Okay. So, because we're dealing with a normal distribution, right? Central limit theorem allows us to approximate something so we can use the normal distribution. We're going to find a z-score, right? So here, we simply apply this formula, something to get super familiar with. I'm even going to write it in a different color. That's how serious I am about it. X minus mu over sigma, right? X minus the average, the expected value divided by the standard deviation. So we are going to find, probably need a much larger parenthesis for this, 2,450 minus 2,500 over, not 2,500, because we need the standard deviation, not the variance. It's going to be the square root of 2,500. And that's going to be less than or equal to S minus 2,500 over square root of 2,500 which must be less than 2,600 minus 2,500 over the square root of 2,500. Now I gotta figure out the values for all these. So going to my good old TI-30, the recommended calculator for ExamP, I find that this value is -1 less than z, right? I like just compressing all this. It's z-score, easier to just call it z, which is going to be less than, quick number change. Ooh, nice and clean numbers, 2. Okay, so what does this mean? The reason we did this, something that's going to make this really easy, is now we get to use a normal distribution. So we're looking for a z-value in between -1 and 2 on the normal curve, right? So you should be familiar with using a normal table. I have one on a screen in front of me. I don't have it printed out, but this is something that you should be super good with. And I'm just going to kind of draw out a visualization. So say we got this normal curve here, right? The standard normal has an average, an expected value of 0, and standard deviations 1. So that's 1, that's -1, -2, that's 2, right? And what I'm looking for is the area from here to here. And there's no real clean way to do that. It's going to be in a series of steps. What's going to happen is I'm going to first find the area from here back, right? The CDF. That's what the normal table actually does for us. Everything behind -1. Then I'm going to find the area for everything behind +2. And all I have to do is take away the bit where I find the entire area for -1, and I should have the area in between -1 and 2. Okay, so hopefully that visualization is really clear. I like these kind of questions because pictures make things so much easier. I even say it to a lot of the younger students I work with, whether you're in 7th grade or whether you're a professional, drawing a diagram makes things so much easier. So yes, we're looking for a z-score for -1. Okay, the z-score for -1, oops, sorry, my normal table turned off. Super useful. All right, so this is going to be phi of 2 minus phi of 1, or sorry, phi of -1. But our normal table doesn't have negatives on it. Some do. The one we're given, unfortunately, doesn't. So we can convert this to becoming phi of 2 minus 1 minus phi of 1. And if you're unfamiliar with what I did here, I don't have time to go into it now. I do recommend studying this on your own, finding the actual numbers. Okay, I can actually distribute the negative out, so I still have phi of 2 minus 1 plus phi of +1. And I finally get 0.9773 plus 0.8413 minus 1, and Okay, a final answer of 0.8186. And that would be answer choice B. Okay, so let's go over what just happened, right? We're given, these policies. There's 12,500. They're identical. They're independent. So I can use the central limit theorem to describe the total. Okay? Now that I'm using the central limit theorem, I know I'm dealing with a normal distribution. Important values, I'm dealing with a normal. You need the expected value. You need the standard deviation, right? Now, once I've gotten those, I'm able to calculate a z-score. I'm in between these two values, right? Not, the probability that I'm less than this number or greater than this number. I need both of those situations. Use the formula for a z-score here. Okay, I get my z-values. I'm looking for the area on the standard normal curve in between -1 and 2. Now, after that, it's just using your lookup table, right? Using the table they give you to find the appropriate z-scores. And then after that, it's just arithmetic, some replacement, and you end up with 0.8186, rounding to answer choice B, 0.82. If you have any questions, if there's anything you need me to clarify, throw it down in the comments. I'll answer to the best of my abilities. If this video helped you out, hit the like button because that really helps me out. And if you have anything else you want to go over, I have a playlist. Sample questions by the Society of Actuaries done out. Please check that out if you need the help. Other than that, hopefully this helps.